In this video, we are going to have a look at how to use TI-84 to solve a differential equation by using Euler's method. We will look at one differential equation example such that it has one independent variable and one dependent variable. So this differential equation is given by dy over dx equals to y over 4x, where the initial condition is y equals to 3 when x equals to 2. And we are going to use the Euler's method of step length 0.1. We are going to estimate the value of y when x equals to 2.3. Euler's method is actually a type of approximations related to sequences. In order to let TI-84 to manage this, we will first try to press the mode button, and then we look at the fifth question. There are four choices: function, parametric, polar, and SEQ, which represents sequences. Then we choose the fourth option, and then press enter. And then we can go back to the main menu, and then press the button y equals. We can see that after we change the GDC into its SEQ mode, this page suddenly becomes the input of the sequences. Before we try to fill in any information, we will try to have a look at the structure of the Euler's method. And from this system, we can see that the future values of x and y may depend on the previous values of x and y. For the case of only one independent variable and only one dependent variable, we will have the following: xn plus 1 equals to xn plus h, which means the next value of x is equal to the original value of x plus the step length h. Then we can see that the formula for y will be a bit similar to the formula for x, but we have one extra component in the second term on the right hand side. From the system, we can see that the next value of y is equal to the original value of y plus the product of the step length h and the value of dy over dx at the original point x and yn. From this system, we can see that the right hand side of the equations are in terms of the original coordinates xn and yn, which is important for the coming input. Then we will go back to the input page of the SEQ mode. We suggest that for the type of the sequences, we can choose the middle option called SEQ bracket n plus 1. It is because this notation would be consistent with the version in our formula book. And then for the next question, n minimum, we will suggest that we can always choose 0, which also corresponds to the starting point position. From this differential equation, we have two variables, x and y. Then in our input, we are going to consider the small letter u represents x, and then small letter v represents y. Next, we are going to show you how to input the first equation of the system to the GDC. From the first equation of the system, we have xn plus 1 equals to xn plus 0.1. Then on the left hand side, u bracket n plus 1, just like xn plus 1. Which means the first term on the right hand side, we are going to input xn first, which is equivalent to un. In order to input un, we can try to press the alpha button, and then y equals, and then we can go to the last menu. The last menu will show us the necessary notations we need. Input xn, that means we want to input u bracket n, so we choose the first option, and then plus h plus the step length, which means plus 0.1. When using the Euler's method, we also need to input the correct initial boundary conditions. u0, which means at the beginning what would be the x coordinate. From the question, we know that the initial value of x is 2, so that we try to input u0 equals to 2. Usually, we just need to input one initial value of x, so we can try to skip u bracket 1, and then we go to v bracket n plus 1. Then we try to check the system again. The second equation is yn plus 1 equals to yn plus the step length 0.1 times the derivative dy over dx at xn yn. which means on the right hand side, the notation should be in terms of un and vn. Then we will try to input vn for the first term, so we try to press the alpha button again, and then y equals, and then go to the last menu, and then this time we choose the option 2. And then plus 0.1. Up to now, this looks like the formula for u bracket n plus 1, but this is not yet the end for this particular formula. 0.1 times the following, so we try to use the bracket. Inside the bracket, it should be the expression of dy over dx at x and yn, which means inside the bracket, this expression should be in terms of un and vn. We can refer to the differential equation. We have dy over dx equals to y over 4x. So that we can try to input y over 4x here. By pressing alpha xt theta n, we generate a fraction template. At the top, yn, that means vn. And then at the bottom, 4x, that means 4 times un. And then close bracket. v0 represents the initial value of y. From the question, we have the initial value of y is equal to 3. Only one initial value of y is needed, so we can skip the question v1 at this moment. Before we try to look at the summary table, we can try to press the second button and then the window button to double check the setting for the table. In Euler's method, we can always try to make sure that table start at 0 and then delta table equals to 1. Table start means the starting point of the table, and delta table means the increment of the value of n for each time. For the remaining two questions, we can try to set the default to be auto, and then we can press the second button and then the graph button. And from this summary table, we are going to estimate the value of y when x equals to 2.3. As x is represented by the small letter u, we can refer to the second column and then look at the row corresponding to u equals to 2.3. Then if I wish to approximate the corresponding y value, we can look at the same row and then look at the third entry. Then we can see that v bracket 3 is the corresponding value of y when x equals to 2.3.